in the first half of the class, we just talked about in this section with triangles and just finding out sine, cosine, tangent of these guys. That's fine. Most problems, definitely most problems in trig and every problem in calculus, they're not going to have a triangle there. They're not going to care if you can divide two sides of a triangle and get the sine or the cosine. What we're going to learn how to do, though, is figure out what the sine, cosine, tangent, etc. of an angle is without using a triangle, without using a calculator. And you'll see that some of the angles are very easy to figure out or to memorize, and then once you know a few of them, you can use that information to find a whole lot more. And this can be a little bit tricky, so I want you to watch this as many times as it takes to get the hang of this particular part of the course, because this is very important. So let's move on and do that. What I'm going to do is I'm going to draw a little chart up here in the upper right-hand corner of the board here. I'm going to leave that chart in place, and we're going to use that chart probably for the rest of the lesson here. What we want to do is do the following, okay? What you'll have, and I know you won't quite understand exactly why I'm doing this right now, but we'll have tangent, we'll have cosine, we'll have sine, we'll have theta in degrees, and we'll have theta in radians. Okay? And then what we will have is, and again I'm going to explain why I'm doing this, okay, to you in a second. These are the important angles for you to remember. Pi over 6, pi over 4, pi over 3. You know, the unit circle, as we talked about, has infinite angles, okay? But there are some important ones that you really need to try to memorize. And these are they, okay? You have pi over 6, pi over 4, pi over 3. We'll go back and we'll talk about it in a second, but to kind of jog your memory, hopefully, from the previous section of the class, pi over 6 is exactly equal to 30 degrees in regular degrees. Pi over 4 is equal to 45 degrees. And pi over 3 is equal to 60 degrees. Okay. In order to help fill out this table as we move along, what I want to do is draw something right next to this over here. So we'll mark this off like this. Okay. And then what we're going to draw up here is a unit circle. Like this. Okay. This is a unit circle. And what I mean by unit circle, you'll find out here in just a second. This is the x-axis, this is the y-axis. Okay? Now what I'm going to do is here, this is positive 1. Here this is positive 1. This is negative 1. And this is negative 1. Okay? What I'm going to do is draw a circle that goes through all of these points. And my circle looks a little bit more like an ellipse, but it's supposed to be a circle. And the reason this is called a unit circle is because the radius is equal to 1, because I'm intersecting 1 everywhere I go. There, okay? All right. The next thing I'm going to do is I'm going to draw a generic triangle in here, like this. And the triangle is going to go up and touch the unit circle here, and then it's going to come down and cross the x-axis. Okay? Now, just like we've been doing for all of our triangles, this angle is going to be theta that's going to be in there. Okay? So this is just kind of going back to the previous problem. We have a triangle and I have an angle. You have an opposite, an adjacent, and a hypotenuse. The only thing I've done differently is I've drawn this thing on a circle that has a radius 1, and it's called a unit circle. You'll hear about that all over the place. But it's just a triangle. There's nothing special about this triangle. Now notice, I'm going to draw a couple of things that I think are very, very interesting here, okay, and very, very important. The distance here between the point here on the triangle and over here, which is also called the adjacent side, which is what we've been talking about, okay, this distance, okay, is the adjacent side, but also it's just kind of like the x measurement, okay? It's kind of a measurement along the x-axis, so I'm going to put an x there, okay? This dimension, which again measures the opposite side, is, I'm just going to put a y there. The only reason I put those is because this adjacent side is a measurement in x, so I'll put x. This opposite side is a measurement in y, so I put y. So that makes total sense. Now I'm going to stop what I'm doing here, and we're going to move on, and we're going to finish filling out our table, and that's going to help us immensely as we go. Okay. Here are a few sine, cosine, tangent things that you're going to need to memorize, and I know memorizing is never fun, but this is something you're really just going to have to memorize, and after you memorize them, I promise you that you will be able to use this over and over and over again. Okay? The sine of 30 degrees is 1/2. Okay? So, and I got to be honest with you, the first time I learned this, I sang a song. Sine of 30 is 1/2. Sine of 30 is 1/2. Do that for you. Sing that song. Sine of 30 is 1/2. You just need to memorize that, so do it. It's very important. Okay? Sine of 30 is 1/2. Okay. Cosine of 30 degrees is square root of 3 over 2. That's just something you're going to have to memorize. I know it's a weird fraction, but you just need to memorize that. Okay? Let's continue filling out the sine and cosine as we go down here. The sine of 45 degrees is the square root of 2 over 2. Memorize that. Sine of 45, square root of 2 over 2. The cosine of 45 is also the square root of 2 over 2. So hey, that's at least one that's easy to remember. It's the same for both. Okay? And the sine of 60 degrees is also the square root of 3 over 2. And the cosine of 60 degrees is 1/2. Okay, it's a lot of stuff written on the board, but when you think about it, it's not that terribly bad, and here's why. There's only a few numbers in here. You've got 1/2, you've got square root of 3 over 2, and you've got square root of 2 over 2, okay? And they're all mixed around in different places depending on if you're talking about sine or cosine and the angle, but those are the numbers, and once you know those, everything else follows from it, okay? So what I did, honestly, was remember, sine of 30 is 1/2, sine of 30 is 1/2, okay? And then you just remember the other number is cosine, whatever's left over, because you've already done sine of 30 is 1/2, whatever's left over, cosine of 30 is square root of 3 over 2. I just memorized that. When I got down to the 60 degrees, it's exactly flipped around. Cosine of 60 is 1/2. Cosine of 60 is 1/2. And then whatever's left over for for 60 degrees, sine of 60 degrees is square root of 3 over 2. So you kind of just need to remember that. Now, for 45 degrees, it's simple because it's the same number, square root of 2 over 2, square root of 2 over 2. So you can remember sine and cosine easily, okay? For tangent, remember, I already gave you one trick. Hopefully you remember it. Tangent of theta is just equal to sine over cosine. And that's because you had opposite, well, for this one it was opposite over hypotenuse, and this one was adjacent over hypotenuse. The hypotenuses cancel, so what you end up having is opposite over adjacent. So sine over cosine works just as well as opposite over adjacent. So for tangent, it's easy. Once you memorize these, tangent falls out because you take sine, you divide it by cosine. Okay? So sine is 1/2. You divide it by cosine, which is square root of 3 over 2. The 2's cancel, and you have 1 over square root of 3. Okay? But mathematicians don't like this square root of 3 in the denominator, so you multiply top and bottom by root 3, so you get square root of 3 over 3, because square root of 3 times the square root of 3 is just going to give you a 3. So tangent is just going to equal square root of 3 over 3. I'm doing this down here for those that like to understand where this stuff comes from. The end result is really all that you care about, which is that the tangent of 30 degrees is square root of 3 over 3. Okay? Tangent of 45 degrees, remember, is sine divided by cosine. You will use this over and over again, so that's why I keep writing it. Sine over cosine is just equal to 1. Sine is this, cosine is this. It's equal to 1. Okay? And then tangent, again, sine over cosine is going to be square root of 3 over 2 over 1/2. Square root of 3 over 2 over 1/2. These go out, so then you're left with square root of 3. So this is just equal to square root of 3. Okay, now we have built a very, 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 very important table. I can't even stress how important this table is in the context of trig and pre-calculus. This table is really your life, okay? This table is going to be used over and over again, okay? So what you have is sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. tangent of 30 is square root of 3 over 3, and you just kind of go here. For 45 degrees, it's square root of 2 over 2, square root of 2 over 2, and of course, divide those by themselves, you get 1. Sine of 60 is root 3 over 2. Cosine 60 is 1/2, and then you divide these two to get the tangent. Now notice you can also get the cotangent, the secant, and the cosecant. I didn't put them in this chart because I don't want to make it too complicated. But really, if you go cotangent, you can go look on your rainbow and you can figure that's 1 over the tangent. We already figured out what the tangent of these angles are, so if you wanted to put cotangent and keep going out here, you would just 1 over tangent, 1, and then for the other one would be 1 over sine and 1 over cosine. And you could build your chart out to the right and get these easy as pie, but that's not going to really be too useful. Now, the one thing in this chart that I haven't mentioned much is the radian measure. I sing my song in terms of degrees, but really what's useful mostly in trig and calculus is the radian measure. And really that's not too bad either. All you need to remember is a couple simple little things, and I've hopefully tried to instill those few things in you already. But really what you need to remember is anytime you have a 4 on the bottom, if it's pi over 4, 3 pi over 4, 4 pi over 4, or whatever, you have a 4 on the bottom. That's going to imply it's going to be some 45-degree angle, whether it's here or here or here. We'll have to count around the unit circle to figure out where, but certainly pi over 4 has a 4 in the bottom, so that's like a 45-degree angle. Okay? Pi over 3, it's kind of opposite. For pi over 3, that's 60 degrees, and for pi over 6, that's 30 degrees. So they're kind of opposites of each other. I'm trying to give you quick ways to remember what the degree angle is based on the radian angle, and this is how I do it. When I see a 3 in the bottom, I say, okay, it can't be 30 degrees. It's opposite of that. It's 60 degrees, or I guess it would be double, 60 degrees. And for the pi over 6, it would be 30 degrees. So don't fall in the trap of thinking pi over 3 equals 30 degrees. It doesn't. It's 60 degrees. Pi over 6 is 30 degrees. Okay? And once you have that and have this table committed to memory, which you will only be able to do by working problems, the problems in the section become very, 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 very simple. Okay. Let's go back to our unit circle, which is this right here. Okay. What I want to do is I want to go through a couple of angles. Okay. And go from there. Let's say that I have this angle theta, okay? And let's say theta is equal to pi over 6, okay? Pi over 6 is 30 degrees, okay? 30 degrees. Anytime I have an angle on a unit circle, which is basically any angle that you'll ever look at, okay? And I'm trying to explain what does sine, cosine, and tangent mean, okay? As you have this angle, and as this angle moves around, when you take the sine of it, okay, if you imagine this angle is drawn by this triangle and it's here. When you take the sine of this angle, what you are doing when you press the number on your calculator or when you find the answer is what you are doing is you are finding the y component here. You are finding the y component along this unit circle here. So if this were 30 degrees, this angle, okay, pi over 6, 30 degrees, and I calculate the sine of it, then what this means is if I draw this triangle to the unit circle and I measure this, what I'm going to measure is 1/2. Remember, this unit circle is a unit of 1, okay? And so this measure has to be less than 1, and it's equal to 1/2. If I were to take the cosine of this angle and press that button on my calculator, what I'm going to find, okay, is the measurement along x, okay? And this measurement is defined by x right here, and it goes from here to where this triangle stopped. That's x. And if I measure it with a ruler, I would get the number square root of 3, put that in your calculator, divide it by 2, and that's what I would get. Okay? If I take this number and I put the tangent in there, I just divide this length by this length, and I will get this number here. So you can see, if you can mentally just take this triangle and kind of move the line like this angle would get obviously bigger or smaller. And as you moved along the unit circle, for instance, if you move to here, then the y component here would be much more than it is here, and the x component would be smaller if my triangle were here. So if I take the sine of this angle, it's going to be bigger because sine means y, or sine is related to y, and cosine is related to x, so that would be a smaller number. And you can see that as I go up to like 60 degrees, that's exactly true. The sine is a bigger number, and the cosine has gone to a smaller number. Okay? So as you move around the unit circle, when you take sines and cosines, all you're doing is you are finding the length along the x-axis and the length along the y-axis. Okay? And it's as simple as that. Now notice in this quadrant, y is positive because I'm going up, and x is also positive because I'm going to the right. Let's say I had a different angle. Let's say I was operating over here, like this. Okay? The angle here is this right here. Okay? That's the angle. But again, whatever this angle is, I'm going to define this angle by another Greek letter called phi. Okay? What I'm going to be interested in finding is this length and this length, which would be, this would be x, and this would be y. And if I put this angle, whatever it is, in the calculator and I find x, I'm going to get a negative number, because I'm measuring, for cosine, I'm measuring x, and x is going negative. And then for sine, I'm measuring y, which goes positive. So just to remind you here, this is something else you need to memorize. Cosine involves x. That's what I told you before. Sine involves y. That's what I told you before. In fact, it more than involves it. That's what it's equal to. Okay? That's exactly what it's equal to. The reason it's equal to this, when you think about it, is cosine, we already said, was equal to, for instance, adjacent over hypotenuse. Okay? So if I'm looking at this angle, the cosine of this is equal to the adjacent, which is the x thing that I've kind of outlined here. That would be the adjacent, over the hypotenuse. But this is a unit circle. The hypotenuse is always 1, no matter where you put it. So it would be the adjacent, which would be x, over 1, and that's just going to be x. So that's why the unit circle is useful. Because when you're operating on the unit circle, and by the way, you always will be, okay, and you start taking sines and cosines, all you have to do is start looking at the x and the y component of that triangle. That's all you're doing. In this quadrant, if you take the cosine involves x, so your cosine is going to be positive, okay? If you're over here and your angle's way over here, like a bigger angle, like 135 degrees or something, and you take a cosine, then cosine involves x, and you're going to be operating over here, and you're going to be looking for this x component underneath your line here, and you're going to get a negative cosine, okay? And as you go down here, again, if you were to go down here, like this, and if your angle was all the way around like this, then if you were taking a cosine, again, it would be negative, because you're looking at the x component here, and this is a negative x. Your y component would also be negative because it's down here. So I'm going to go ahead and erase this now because the drawing is getting pretty busy. But I hope I've planted the seeds of what we're doing here, and I plan to give you more examples as we go and show you what I'm talking about. So let's do that. Let's take an example. Let's say the problem is, what is the sine of 5 pi over 6? That is the problem here, okay? And you need to find the answer. The first thing you need to look at is, I have a chart. This is 5 pi over 6. I know what pi over 6 is. So the answer is going to be 1/2, but you just don't know the sign of it yet. You don't know if it's positive or negative. But you know that the magnitude is going to be 1/2. That's why this chart is useful. What you need to figure out in your head is if it's going to be positive or negative 1/2. So let's figure that out. Okay, I'm going to draw a coordinate axis, and by the way, this is exactly how you do it. Okay, pi over 6 is 30 degrees. You need to remember that. So this is roughly 30 degrees. So this is pi over 6. But that's not what the problem is involving. Okay, 2 pi over 6 is up here. 3 pi over 6 is up here, which is just simply equal to pi over 2. Remember, we had 0, pi over 2, this was pi over here, and this is 3 pi over 2. Okay, so we have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 here, and 5 pi over 6. So this is 5 pi over 6. Okay? So now that we know where 5 pi over 6 is, I'm going to erase this other stuff. Okay? The angle we're interested in is this one. This is the angle 5 pi over 6. But because I've drawn my line here, my triangle actually lies over here. Okay? It actually lies over here. Okay? I'm interested in the sine, okay, which is going to be the opposite over here, which is going to involve y. Okay? Over here, in this quadrant, y is positive. Notice this goes positive y and this goes negative y. So over here, y is positive. So the answer of sine pi over 6, you just look in your chart, it's 1/2, but you need to figure out if it's positive or negative, and you just found that it's positive 1/2. Okay? Okay, now moving right along, let's go ahead and keep the same drawing up on the board here, and let's work a similar problem. Let's say we were asked to find the cosine of 5 pi over 6. The angle 5 pi over 6. First thing you do is you look and you say, okay, I got 5 pi over 6. I know what pi over 6 is because the cosine of pi over 6 is simply the square root of 3 over 2. But the only thing I don't know is because this angle is going to lie in some other quadrant other than the first quadrant, which is how this table is defined, the cosine may be plus or a minus, and I don't know off the top of my head what that is. I need to figure that out. We've already figured out that 5 pi over 6 is over here in this quadrant, because you've got pi over 6 at 30 degrees, 2 pi over 6 at 60 degrees, 3 pi over 6 at 90 degrees, which is pi over 2, 4 pi over 6 here, and then 5 pi over 6, so it's in this quadrant over here. I'm looking at the cosine, and then I remember the cosine is x, cosine is x, sine is y, so cosine is going to be this measure right here, okay? And if you look over here in the x-axis, this is negative x. This is negative x. I have the number here given by my chart. It's a pi over 6 number, so it's square root of 3 over 2. It's negative x direction, so I put a negative sign in front. So the answer to cosine of 5 pi over 6 is negative square root of 3 over 2. Now finally, one thing I'll just say is, if the problem were just regular cosine, or regular cosine pi over 6, then pi over 6 is in my table, cosine pi over 6 is square root of 3 over 2, okay, and if this were my problem here, where this is pi over 6, well then I would have found, and I'm looking for cosine, I would have been looking here, which is x, which is positive. It would have been positive square root of 3 over 2. Now look over here, the exact mirror image of it is at 5 pi over 6. It's an exact mirror image, and so the angle is negative, but the number is the same. Okay, so as you go around the unit circle, you're going to find that a lot of these numbers in multiples of these angles are the same number, but in fact the sign is different just because as you go around the circle, here is negative x, here is negative y, and so on. So sometimes I'm going to have negative signs as I go around. Okay, that's really all I want to say about that particular problem. Let's go ahead and move along here and work a different problem. And we're going to use this table over and over again, and as we use it, we will learn the material, and it will basically become second nature to use it. So what if you were asked to find sine of 2 pi over 3? Okay. Well, first thing I need to do is look in my table. This is something over 3, 2 pi over 3. So I know it's a multiple of pi over 3. I'm looking for the sine, which is here. So I know that before I do anything else, if I just look at my chart, I know this is going to be square root of 3 over 2, but I just don't know if it's positive or negative, and that's very important. So let's go find that out. All I do is I draw coordinate axis. Of course, this is x, this is y. And now I need to draw and figure out what quadrant this is in. Really, all that matters is the quadrant. If you remember from the previous lesson, up here at 60 degrees, okay, this is roughly 60 degrees, is pi over 3, okay? So this is pi over 3. Add another 60 degrees is going to put you over here. This is 2 pi over 3. Okay? So pi over 3 is here up at 60 degrees. You got basically 30, 60, 90, 120. So over here is 2 pi over 3, which is basically 120 degrees, because 2 times 60 degrees is 120 degrees. Okay? So now that I know where it is, this would be my triangle. If I were to draw that triangle here, it would be over here. And the actual angle that we're measuring here is actually this angle right here. But this line here, this hypotenuse, is defined right here. So basically, over here, this is going to be kind of the sine over here, and over here, this is going to be kind of the cosine. Because remember, x is cosine, y is sine. So, over in this quadrant, which is this quadrant right here, y is positive, so this is a positive. Square root of 3 over 2. Okay? If I were looking for the cosine of 2 pi over 3, first thing I do is I look in my chart. Pi over 3 this is a multiple of pi over 3. I'm looking for the cosine, so that's going to equal 1/2. Okay? And then if I look over here, again, I've drawn it at 2 pi over 3. I'm looking for the cosine. Cosine is kind of like x, okay, along the x-axis. And this is negative x here, so this would be negative 1/2 if I were doing that. So you can see after a little bit of time, it becomes somewhat mechanical. You use your table, you get the value, and then you just need to draw on the circle where the angle lies to find out if it's positive or negative. What if you're asked to find sine of 4 pi over 3? Well, first, again, this is a multiple of pi over 3, so I look at my chart. It's a sine, so this is going to be square root of 3 over 2, and I just need to find out if it's plus or minus. So I'll draw my guy right here, okay? This is a multiple of pi over 3, so again, you start at 60 degrees. This is roughly 60 degrees here. This would be 30, and this would be 60. So this is pi over 3. Okay, right here, this is 2 pi over 3. Okay, 3 pi over 3 is right here. Right on the axis here, this is 3 pi over 3, which, by the way, reduces to pi, which is what we remember before. This is 0, this is pi over 2, and this is pi. So then 4 pi over 3 is going to kind of be 60 degrees down from that, which is going to be more like this. Okay, so this is going to be 4 pi over 3. So we use this to count over pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Okay, so this is the quadrant we're at. So then if this were my triangle, I would be looking at this triangle right here. Now, sine is related to y. You can think of it like this. Sine is y, sine is y, and then cosine is just what's left over, which is x. So if I'm looking for the y here, this is y. Notice that this is the y-axis. This is negative y. So this is a negative number. It's measuring down. It's negative. So this is negative square root of 3 over 2. Okay? Kind of moving through these a little bit briskly, but I think you see the point. Let's say you have cosine of 5 pi over 6. Again, first thing you do is you look for, this is a multiple of pi over 6. You look in your chart for cosine. It's going to be square root of 3 over 2. Next thing you do to figure out if it's positive or negative is look at your chart. Pi over 6, remember, is 30 degrees. So this is pi over 6. So you have pi over 6, 2 pi over 6 right here, 3 pi over 6 here, which reduces to pi over 2, which is what we know the y-axis is. 3 pi over 6. Then you have 4 pi over 6. And then finally, you're going to have 5 pi over 6 right here. Okay? You're going to have 5 pi over 6 right here, and then this would be my triangle like that. And then I'm looking for the cosine, so I'm looking for the cosine, which is the x, okay, which is negative here. So then this would be a negative square root of 3 over 2. Okay? The only thing that you really need to practice here is two things. One is memorize this table to the right. I think you can see how useful it is. And two, go ahead and practice how to draw these angles on the axes, because that's really the only thing to it. Cosine 7 pi over 6, again, it's a multiple of pi over 6. I'm looking for cosine. multiple pi over 6. It's going to be square root of 3 over 2. Now I just need to find out if it's positive or negative. We draw our coordinate axis. Okay? And we start out, this is pi over 6, which is starting out at 30 degrees. So we start out kind of at 30 degrees. This is pi over 6. This would be 2 pi over 6. Okay, right here, 2 pi over 6. 3 pi over 6 equals pi over 2. 4 pi over 6 here. 5 pi over 6 here. 6 pi over 6 here. 6 pi over 6 is just pi, so that makes sense. 7 pi over 6, then, if this is 6 pi over 6, 7 pi over 6 is going to be down here. Then my triangle would be defined like this. Okay? This is cosine. Cosine means x, so I'm looking at this measure along x. This is negative, so this will just be negative. Not too bad, right? Like I say, the trick is just counting your angles, remembering that pi over 6 is kind of a 30-degree increment, and learning how to count there. What if you had sine of 0? Sine of 0. Well, this one's a little bit interesting because it's not actually on the chart. Okay, it's not on the chart because this is 30 degrees, 45 degrees, 60 degrees. This is 0 degrees, which, by the way, is equal to 0 radians. But let me show you, by understanding what we're doing here, you can figure this out. This is the x-axis. This is the y-axis. Okay? What we're looking at is 0 degrees. 0 degrees is here, remember? This is 0. As you go up, you get to 90 degrees and so on. So what we're looking at here is this. We're looking at a line here with no angle because the angle's measured between the line and the x-axis. But if the line lies along the x-axis, the angle's 0. Now, remember, for sine, you're looking at what's the length in y. If the line were up here defining some angle, then you'd be looking at this dimension for the sine, okay? But it's lying along the x-axis. It has no length in this direction. So sine of 0 is 0. It's just as simple as that. Sine of 0 is 0. If you were looking, over here, you would get the same thing. If the angle was way over here along this line, like 180 degrees, sine of 0 would be 0. I mean, sine of 180 degrees over there would be 0. Now, what if you were looking at cosine of 0 while we're talking about this line that's lying across this with really no angle? What's that equal to? Well, remember, this is all defined in terms of a unit circle. So there's some imaginary unit circle going through, from a radius 1 like this. Okay? So when the line goes here, it extends to the boundary of the unit circle. There's no angle because it's laying along the x-axis. Cosine, remember, is a measure along the x-axis. So when the angle lies along the x-axis, okay, the length is just going to be 1 because it's the radius of this unit circle right here. So, a couple simple things to remember. Sine of 0 is 0, cosine of 0 is 1. And they're easy to remember because if you draw it along the x-axis, as long as you remember that cosine is a measure along x, you'll always get the answer 1 in your head. And if you remember sine is a measure along y, then you'll always get the answer 0 because there's no length here in the y direction. Okay? Let's do some other very useful ones like this. Let's say I have sine of pi over 2. Remember, pi over 2 is up here, this line right here. Okay, so this angle would be pi over 2 between this line and this line, which is 90 degrees, by the way. And you can refer back to the previous lesson on that, but this is pi over 2. Okay, and this is 0. Okay? Now, if you're looking for the sine, remember sine is a measure along y. So if the line's up here, the triangle is really, again, not so defined because if it were over here, it would come down to the x-axis. So the triangle's lying exclusively along the y-axis here because we're up at 90 degrees. And so sine of pi over 2, which is 90 degrees, is, again, 1. And it's positive 1 because I'm measuring up here. Okay? If I had a bigger angle coming all the way down to here, it would be negative 1 because there would be, the only thing I'm measuring is along y, and it would be negative. But up here, it's positive 1. Okay? Continuing along this thought, the cosine of pi over 2, what do you think that would equal to? again, the line here is up here at the axis, okay? And I'm taking a measure for cosine that's supposed to be kind of in the x direction, but since the whole thing's lying along this axis, there is no length in the x direction. So cosine 90 degrees is 0. So you'll see that along the boundaries here, you're either going to get 0, 1, or you'll see in a minute, you can also get a -1. Okay? What if you had, taking this a little bit further, what if you had sine of 3 pi over 2, and we're trying to find what is that equal to? Well, again, you have 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. So what you're looking at in this case is along this axis right here, okay? There is no mixture of x and y because it's, remember, sine is along y and cosine is along x, and the sine is going to be measured along the y-axis, but my line lies along the x-axis, so this is just going to equal to -1. The length is 1, and of course it's negative because I'm measuring down along the y-axis. If I had cosine of 3 pi divided by 2, again, I'm down here along this line right here, and cosine means measure along the x direction, but it's lying exclusively along y, so there is no x direction, so you just put a 0 there. Okay? Go down here, you're on there, there's no x direction to it, like in the other examples where I had it out here, I had an x and a y. Here is purely along y, so that makes things very simple. Okay? And then just to mix it up, if I had sine of pi, what would that equal to? Well, again, this is pi over 2. If you remember, this is pi, because this is 0 pi over 2, 2 pi over 2, or rather 0 pi over 2, pi over 2, 2 pi over 2. So this angle is equal to pi, which is 180 degrees. This is pi over here. So my line is lying along this x-axis over here, right? Pi radians rather. And because sine is a measure along y, it's 0 because it's along the x-axis. There is no y component there. Okay? And finally, for this one, cosine of pi. Okay? Again, I'm lying along this axis over here, and I'm trying to find out what the cosine is. The cosine is a measure along x. This is a unit circle, so this is -1. It's negative because this is negative x. Okay? So it's very methodical, and I didn't put all of these in the chart because these are, you're going to end up just kind of memorizing what these are or quickly able to draw a unit circle and figure them out pretty fast. What if you had sine of negative pi? Okay, I haven't dealt with negative angles much, but when you think about it, this is positive pi. Well, you can also start from here and you can get back to negative pi. Okay, so again, this is the same thing. It's the same place. It's over here. Negative pi is the same as positive pi. It's the same number of radians, just going the opposite way. And the answer is going to be exactly the same. Sine is a measure along y, but I'm over here, so I have no y, so that's 0. And then cosine of negative pi, again, you're going negative over here. So you're arriving here, you're on the x-axis. Cosine is a measure along the x-axis, so this is going to be -1. Okay, so that's a basic primer in what cosine and sine are along the different axes. And remember, everything else comes from that. Tangent is sine over cosine, and you have the secant, the cosecant, and all that stuff, and they're all defined in terms of sine and cosine. So once you understand how to find sine and cosine, the other ones fall out automatically. That's why this chart, I really emphasized this, and I told you the tangent can be derived from the sine and the cosine, and really the secant and all that stuff just falls out. Let's work a few more problems. What if I had the tangent of -5 pi divided by 4? It's a negative angle, it's 5 pi over 4. First thing I need to realize is that this is a multiple of pi over 4, which is here. The tangent of pi over 4 is 1. So I know that a 1 is going to be involved in this somehow. But all I need to figure out is it +1 or -1? Again, the way you do that, you draw your coordinate axis, and you put this angle on it, and then from there you can figure out if it's going to be positive or negative. Okay? what you really need to do to figure that out is the following. Let's plot the thing here. This is 0, okay? This is, remember, pi over 4 is 45 degrees, so right here in the middle, this is going to be negative pi over 4. This is negative 2 pi over 4. This is negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4 up here. So this is going to lie up here. Negative 5 pi divided by 4. Okay? Negative 5 pi over 4. So you start here, you go negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4. You get up here. And we know the answer is going to be 1, we just don't know if it's plus or minus 1. But again, we're going to be interested in this stuff over here. Okay? This length is going to be the sine of this angle, and this length is going to be the cosine of this angle. The way you figure out if it's plus or minus for the tangent is like this. Remember, tangent is just equal to sine over cosine, right? So in order to figure out if tangent is going to be plus or minus, I just need to figure out, is the sine of this angle going to be plus or minus? Is the cosine going to be plus or minus? And based on that, I can figure out if tangent is going to be plus or minus. So let's look. Sine of 5 pi over 4, sine of pi over 4 is this. So this is going to be a plus, because y is positive. And if you want to be fancy, you can even look in your chart, and you can see that the sine of this is going to be positive square root of 2 over 2. The sine of negative 5 pi over 4, because we figured out it's in this quadrant, it's positive, and it's square root of 2 over 2, looks like that. The cosine lies down here, and again, the cosine is also square root of 2 over 2, but the cosine is negative, because the cosine lies along the negative x here. So this is negative square root of 2 over 2. You can see right away the tangent's going to be magnitude 1, because this is going to cancel with this and give you 1, but here I've got a positive divided by a negative, so it's going to be negative 1. Okay? So the table, again, gives you the right answer, 1, but in order to find the sine for a tangent, you need to go find the sine of the, when I say sine, you need to find out if it's positive or negative, if the sine is positive or negative, if the cosine is positive or negative, and then you can find the answer. If for whatever reason your sine was negative, then you would have negative over negative. That would give you a positive tangent. So it's important to find both of them. It's very important to find both of them. Okay. And to kind of give you an example of that, let's say we were finding the tangent of negative 3 pi over 4. Okay, let's plot this. Okay, this is negative pi over 4 at negative 45 degrees. This is negative 2 pi over 4. This would be negative 3 pi over 4 right here. So I would be interested in this right here for the triangle. I'm trying to find the tangent. Tangent is equal to sine of negative 3 pi over 4 over cosine of negative 3 pi over 4. I've already drawn my triangle. This is negative 3 pi over 4 right here. The sine is going to be square root of 2 over 2, and it's going to be negative because sine is along the y-axis, and this is negative, so this is negative square root of 2 over 2. Cosine is going to be this measure right here. Again, this is negative because this is negative x. Cosine relates to x. This is negative x. And the magnitude is given by this right here. This is negative square root of 2 over 2. Well, you can see right here, this is just going to equal positive 1. So for tangent, in order to find the answer, you really need to find the sine and the cosine. And just remember, tangent is equal to sine over cosine. And then you can just go from there. Okay, the next thing I want to briefly touch on, because it directly relates to what we've been doing here, is what we call the inverse trig functions. Up to now, I've been giving you an angle and saying, find for me the tangent, the sine, the cosine, whatever of that angle. I've given you an angle and I've said, give me the sine of that angle. And we've put the angle on the unit circle, and we figured out if it's positive, negative. We used our chart and all that stuff. Now, what if you're not given that? What if you're given that the sine of the angle is equal to some number. How do you find what the angle is? Previously, I've given you the angle and asked you to give me the sine. What if I give you what the sine of the number is and then ask you, what's the angle? What's the angle? Well, that's how we're going to do these problems here. And we're just going to do a few of them. But what if you have sine, I'll tell you what this means in a second, 1/2. What would this equal to? This notation is called inverse sine. This -1 up here, it doesn't mean 1 over sine. Okay, it does not mean that. Okay, this is just a reminder to you that it's the inverse sine. What I'm asking you here is, what this translates into is sine of some number theta is equal to 1/2. This is what this really means. And what I'm asking you to find is theta. What angle exists such that when I take the sine of it, I get 1/2? That's what this means by inverse sine of 1/2. Okay. Well, immediately I can look at my chart and see sine of pi over 6 is 1/2, right? That makes total sense. Let's figure out how that would work. If I drew here at pi over 6, okay, then this sine here, this vertical measurement here along the opposite side, this sine would be 1/2, and that's exactly right. That is one answer. So I could have pi over 6. That could be one angle, okay? That would give me 1/2. But we've already said that if you look over here at the mirror image, what about this? What if this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6? What if I look at 5 pi over 6? Well, I'm going to have the same, because it's a mirror image, I'm going to have the same vertical measurement here. It's also going to be positive because I'm measuring along y. Okay? So, bottom line is there's two angles that can satisfy this. Okay? If you were to take the sine of pi over 6, you would definitely get 1/2. If you were to take the sine of 5 pi over 6, you would still get 1/2. And that's because of this. Because if you're looking at the sine, you're looking at this measure, which is exactly the same as this measure. So frequently when you're doing inverse sine, inverse cosine, you're going to get multiple angles that satisfy it. And that just is a function of the fact of how you define sine in the first place. Okay? So what if you had another example? Inverse sine of square root of 3 over 2. And this is basically another way of writing sine of theta is equal to square root of 3 over 2, and I need to find theta. Okay? Well, first I can look, immediately I'm trying to find the sine of some angle, and I can look down here and I can say, well, here's square root of 3 over 2. Sine of pi over 3 is square root of 3 over 2, so well, looks like I found at least part of my answer. Okay, this is pi over 3 up here at 60 degrees, roughly up here almost to 90. That's pi over 3. And of course, if this were my triangle, well then yeah, sine would be bigger. It would be, like we have here, square root of 3 over 2. Okay? So one of the answers is pi over 3. That's one of the answers. But again, this is the sine. I can look at the mirror image. We'll look at this angle over here. Okay? I would be measuring, if I use this triangle, the same vertical measurement, same sine, because y is positive in both instances. What angle would this be? Well, this is pi over 3. This is just add another 60 degrees to it. That's 2 pi over 3. Okay, so 2 pi over 3 would be the other angle that would satisfy this. Now, if I keep counting and going 3 pi over 3, 4 pi over 3, eventually, I'll get to some angles down here, but that won't satisfy this because if I take the sine of an angle down here, I'm going to get a negative number. And this is a positive number. So any angles that I find down here aren't going to work out because I'm going to get a negative sign for them. So that's why you look there. And we'll do one quickly with the cosine, and you'll see what I'm talking about. What if I had cosine of negative square root of 2 over 2? Okay, so the next thing I do is I rewrite this, and I say, well, that's another way of saying cosine of theta is equal to negative square root of 2 over 2. So I'm trying to find some angle so that when I take the cosine of it, I get negative square root of 2 over 2. Okay? Well, notice that right away, and this is kind of a tricky little problem, right away I have square root of 2 over 2's here, so I know it's going to involve 45 degrees, but it's obviously not going to be pi over 4 because sine and cosine of pi over 4, they give me positive numbers here. So let's just draw our unit circle and try to figure out what the answer here is. Obviously here at pi over 4, that's not going to cut it because cosine pi over 4 is a positive number along the x-axis here. It's positive square root of 2 over 2. But, this is pi over 4, this is 2 pi over 4, 2 pi over 4, which reduces to pi over 2, which makes sense for the y-axis. 2 pi over 4, okay? This would be 3 pi over 4. This would be 3 pi over 4, okay? If I were interested in 3 pi over 4, this would be the triangle here, defined like this. And if I'm looking at cosine, cosine is along the x-axis. Again, I would say pi over 4, well, the magnitude is going to be square root of 2 over 2, okay? But this is over here in this quadrant, so this would be negative because x measure is negative over here. So this makes sense. So the first angle that satisfies this is 3 pi over 4. And that satisfies it because in the chart, this is the magnitude here, which agrees with this, but I'm trying to find the angle when the cosine is negative. And here the cosine is negative because I'm in the negative x direction here. Now let's keep going. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, okay? 5 pi over 4 down here. If I were looking at this, this would be the guy here, 5 pi over 4, again, pi over 4, 2 pi over 4, 3, 4, 5 pi over 4. And this is going to give you the same answer because for 5 pi over 4, if I'm looking at the cosine of it, I'm looking at the x direction here, which is this x measure right here. And this is, again, negative. So it's going to give me a negative, and it's going to give me square root of 3 over 2 because my chart tells me that anything with a 4 in the denominator is a multiple. It's going to give me square root of 3 over 2. So the answer is 5 pi over 4. Okay? So to summarize, when you're given an angle and you're asked to find the sine or the cosine, you look at the chart, you put the number down that you think is right based on if it's a multiple of this angle or not, and then to find the actual sign of it, if it's positive or negative, you just put the angle in the proper quadrant, and then you look to see if the x or the y is negative there, because sine relates to y and cosine relates to x, so you look at the quadrant to figure out if it's positive or negative. That's why that's important. If you're trying to find the inverse, okay, cosine, all you're trying to do is find the angle that satisfies what they give you here. It's kind of working the problem in reverse. In that case, you again look at your chart, try to find something that matches, and again, look at your quadrants to figure out what quadrants would give you whatever cosine or sine you're looking for, and then those are the angles that you will be interested in finding.